So we'll review again on Friday. And then we'll be ready to go on Monday. And the test is real short. I think you can see that. Here we go. The first section of the test, this practice test, there's 5 sections on the test, and one of the sections has to do with all this function stuff. So, what does this mean? What am I going to do here? I'm going to find m of n of x. So, what does that mean I do? Matthew, do you know what I do? Yeah, so I start with n of x right here. I figure out what that is. Well, n of x is x squared plus 2, right? So that gets plugged into m. So in the m function, every time I see an x, I put in x squared plus 2. So my final answer is 4x squared plus 8 minus 3, or 4x squared plus 5. Okay? All right, what's going on here? What does this mean? What am I supposed to do here now? Plug 2 into m. So if I plug 2 into m, what do I get? Put a 2 right here. What do we get if we put 2 in there? 5. All right, now I'm going to put 3 into n. And what do I get? 11. And the problem tells me to subtract those 2, so the answer is negative 6. Now, unless you make careless arithmetic errors, you really can't miss that, right? That's pretty easy. All right, what's the next one mean? M of n of 1. What do I need to do? Put 1 into n. So I'm going to put 1 into n. So what do I get when I put 1 into n? 3. So I'm going to find m of 3. So that means I'm going to put the 3 into m, and that gives me 9. One goes into n, and then that answer goes into m. Everybody good? Okay. Now, what am I doing here? Don't make this hard. This is easy. All you're doing is what? Multiplying the m function times the n function. And that's going to mean foiling in this problem. It means foiling. So 4x cubed minus 3x squared plus 8x minus 6. Now, when I foiled it in the order that would give me descending order. When you write your final answer, make sure that it's in descending order, okay? If you foil this, F-O-I-L, it won't come out in descending order, which is fine. Just rearrange things and put it in descending order. Easy? Yeah, easy. All right, speaking of easy, find implicit functions. What does that mean? We're on problem set number 2 now. Number 2. What does that mean? Get y by itself. Okay, that's easy. Square root both sides. And on the test, I'm so nice. I even write y equals and y equals to remind you that there are 2 answers. One of them is the positive square root of 6 minus 2x squared, and the other one is the negative square root of 6 minus 2x squared. We don't ever try to simplify those, because almost never do they simplify. You might think they simplify if you saw something like this, but that doesn't simplify. Don't do it. Don't do it. It will be wrong. Just leave them alone after you square root both sides. All right, that was easy enough. Let's see what's in the next section. Find the domain. Okay, now be careful. What can't equal 0? What can't be 0? There's something that can't be 0. The denominator. So we got to remember that if it's a denominator, it cannot be 0. What else do we have to remember? If it's under a radical, if it's under a radical, it has to be greater than or equal to 0, right?
Yeah.
Okay, so with that in mind, let's look at problem A. It's a radical problem. Whatever is under the radical has to be greater than or equal to 0, so x has to be greater than or equal to 1, and that's your answer. You gotta learn the rules. If you learn these 2 rules, then all these problems are easy. All right, the next one. The next one has a fraction. So what do we know about fractions? The denominator cannot be 0. So the denominator cannot be 0. So we just solve it. So x can't be 1/3, and that's your answer. C. What about C? All real numbers. Why is that one all real numbers?
Because there's no fraction in there. It's not
Exactly. Boys and girls, this is the problem right here. These are the issues. If you don't have the issues, then you don't have the issues. It's all real numbers. And then the last one. Well, you got to be careful because on this one you have both issues. You have a radical, Malcolm, and what do we know about radicals? Whatever is underneath has to be greater than or equal to 0?
Yes.
So x has to be greater than or equal to -2. That takes care of the radical. But we also have a fraction. So x minus 3 cannot be 0. So we have 2 answers to that. You have the 2 things in the answer blank. You got to be bigger than or equal to -2, but you can't be 3. Everybody good? All right, next we're doing some sketching. All right, most of these are just your BFFs moved around. So what shape are we going to have for this first problem A? What shape will that be? A V shape. But instead of being out of the origin, it's going to be shifted how?
To the left.
To the left 2 and up 1. So I'm going to put a point, left 2 and up 1. I'm going to label it, and I'm going to draw my V.
On the test, do we need a label?
Yes.
Wait, so whatever is in the absolute value, you do the opposite?
Yep.
Okay.
All right. Number 2, or B. Now, sines and cosines, you got to be a little bit careful with these guys. So I like to start with my regular sine curve. Okay, now my regular sine curve starts at the origin, right?
Yes.
And the hills go up 1 and the valleys go down 1. So the valleys go down 1 and the hills go up 1. Now, when I draw my sine curve, I'm really, really careful. Most of you are pretty good about this part. You're getting that part, okay. Over here, don't do this. You can't have 2 hills next to each other. It's got to go this way. You got to have hill and valley, okay? So that's my normal sine curve. Now, what's happening in this equation, though? Going up 2. That means that every piece of this picture is going up 2. So that dot, which is at the origin before, is now going to be here, isn't it? And if you want, if it helps you, you can draw a line here, because isn't that where we're going up 2 and down 2 from, or I mean up 1 and down 1 from now?
Yes.
So if that helps you, you can go ahead and do that. There's your picture. The purple one is the answer. So I very carefully drew my original sine curve, the one I have memorized, and then I just picked it up 2. Got it?
Yep.
Okay, gotta do that carefully. C is not tricky at all. What shape is C? C is a parabola. And your normal parabola, of course, is vertex at the origin. So it looks like this. That's your normal one. What has happened to this one?
It goes down and then down 1 to left 1.
To the
Right,
right
right.
one.
That's
Right one.
Right.
That's right 1, and that is down 1.
Is it the opposite when it's in parentheses?
Yes. Emma just asked that question. So it's right 1, down, need 2 commas, right 1, down 1, and there's my parabola, my nice little parabola that's right 1, down 1. All right, what about D? What shape is D?
Like a
It's your
It's a
squiggly,
That's a squiggle.
the squiggle,
Yeah.
yep. And the normal squiggle is through the origin like that.
Yeah.
That's the normal squiggle.
Oh, but this one's
Well,
really
this
down
one
negative
has been
2.
shifted
Down
Left.
2.
Down 2.
Left.
left
Oh.
2,
Left 2.
left 2. That 2 is inside the parentheses. That's a shift this way. So we have gone left 2. So I'm going to plot that point, left 2, and then I'm going to squiggle through that. So instead of squiggling through the origin, I'm squiggling through
That.
negative 2, 0. Kids, this isn't hard. If you remember what your shapes are. All right, what's E? What's happening there?
Square.
That's
Square
your
root.
square root.
Yeah.
And you know that the normal square root comes out from the origin, right?
Yep.
So we're going to have that exact shape, but it's not coming out from the origin. It's coming out from what point?
1.
Which way is this going?
Right.
Whoa, whoa, whoa.
I mean,
Which way is that
left,
going?
left, sorry.
That's going left 1
Down
and
two.
down 2. So left 1 and down 2. And then my shape. So negative 1, negative 2. And then my square root shape. And then we've got our handy dandy piecewise function. Now, remember kids, the practice test is like the test. So you are going to have to do a piecewise function on the test.
Oh.
All right, so here we go. I know I keep saying this, but I really think it's the easiest way to do the problem. I like to draw a dividing line wherever this is right here. I'm going to draw that dividing line. And then I'm going to draw this line right here. Now I know what some of you are thinking, wait a minute, Mrs. Ford, 3x minus 4. Stop. You've done this since you were, little. How do you draw a line? That's a line.
Eyes over
Well, you use the slope, and by the way, the slope is 3 over 1, right? And where do we start?
at the x-intercept.
At the y-intercept, which is negative 4. So I'm going to start right there at negative 4. And I'm going to count up 3 and over 1, and up 3 and over 1. And I'm going to draw that line in. And I'm really, really, really interested in this point right here. That is where my line that I just drew crosses my dividing line. So then I figure out, open dot or closed dot. I look up at the problem, I see it is open. Nice big open dot. And then I figure out, I know every time I do a piecewise function, because I'm only graphing pieces, that I'm going to erase part of this line. I'm either going to erase the left part or the right part. So this is my clue. This says keep the part going this way. So I'm going to keep this part, and I'm going to erase that part. Problem tells you exactly what you want to keep. I want to keep the part that's going this way. Now, what shape do I have here? That's not a parabola.
I mean,
That's a V. That's a V, right? But it's not a normal V at the origin. It's been lifted up one. So I have a V that's lifted up one. Now notice it crosses my dividing line too. They always will. And this time, the dot will be filled in.
Yep.
And I will keep that part of the problem,
Yep.
which means I will erase this part of the V.
Yep.
Now I want it to look really good, so I'm going to get rid of that dividing line, and I can see my piecewise function. Okay, pretty easy. All right, so there's one more section to go. Hi. You're coming E period, the last part of E period. Okay. Yeah, I think like in an hour maybe. Thank you. Okay. So now we have to do our asymptotes. And we got to do horizontal, vertical, and holes. All right, so let's see what we remember from yesterday. Tell me about any of those, horizontal, vertical, or holes.
Oh,
Emma?
horizontal asymptote is, wait, that's, that one would be, it can't be zero, or no, that's a vertical asymptote. So that one would be, wait.
Can't even figure out.
1 second.
I have no idea what you're doing, so you need to
Oh, it'd
clarify.
be,
What will be?
X can't, or it'll be 4/3.
For what? What is it? Horizontal, vertical, or hole? Vertical asymptote is X equals 4/3. Emma is exactly right. I have no idea what was going through that mind, but she is exactly right.
And the next
She
one's
looked at the
2/3.
denominator and said, look, your denominator cannot be 0. So that means X cannot be 4/3. Whatever it cannot be is your vertical asymptote.
And
The vertical asymptote comes straight from the denominator. And then Emma says her horizontal asymptote is 2/3.
And there's no holes.
And there's no hole. She's got this. She's got
Wow,
it.
that was stressful.
It was stressful. The only way you can get a hole is if you cancel. And obviously nothing in that problem cancels, so there's not going to be a hole. All right, number 2.
X can't equal -5.
So we have x squared minus 9 over x plus 5. Okay, so my vertical asymptote is -5.
Yes.
Remember, vertical asymptotes are what make the denominator 0. They're the cannot be's. So we cannot be -5. Right?
Yeah.
Okay, horizontal asymptote.
None.
None. Because the power on top is bigger. And when the
There's no
power on top is bigger, there is no horizontal asymptote. If the
There's no
power on the
holes.
bottom is bigger, it's y equals 0.
0.
Holes? None. Now, some of you might be saying, oh, but Mrs. Ford, you can factor the top. Yes, you can. But you can't cancel, right?
So it don't matter.
So it doesn't matter. That's right. It does not matter. All right, last one. Last one, and we'll have the practice test done. Here we go.
Really?
That's it. It's that simple, but this is a big one now. What do you want to do with this problem? You better factor it, yeah. And I think when you just look at it, you factoring like occurs to you. I think I should factor this. So if I take a 2 out,
Yep.
so my numerator is x minus 4, x plus 4, along with the 2.
Yep.
Uh-huh.
And then my denominator is plus 5 minus 4.
It does
X
cancel.
minus 4
It's
cancels.
not
We got a cancellation, so
So you have
that
four.
means I will indeed have a hole. Okay, so let's back up over here. I'm going to have a hole in this picture. Okay, doesn't matter, might as well. I know the hole is a point. And the factor that I canceled out gives me the x coordinate. So I canceled out x minus 4. So I'm gonna have a hole where x is 4. It's the opposite, like it's always the opposite, right? Now how do I get the y part of that point?
You plug in 4.
I plug in 4 right here. Do not go back to the original. First of all, it's way harder, and second of all, it'll never work. You always get 0 in the bottom. So put the 4 in here. So I have 2 times 4 plus 4 over 4 plus 5. So what is that? 4 plus 4 is
That's gonna
8.
be 2.
I think it's 16 over 9, isn't it?
How did that happen? How did you get
4 plus 4 is 8, times 2 is
She
16.
thought it was 16.
2? Oh, I thought it was 18. Sorry, excuse me.
Alright, so does everybody get where the hole came from?
Yes.
Okay, Maya, you awake over there? Okay. Alright, now what about my asymptotes? Look right here. Tell me about my asymptotes. Vertical will be at x equals
-5.
-5.
Horizontal is 2.
Horizontal is y equals 2. And you can get that by looking right here. Don't you have 2x over x?
Yep.
Or in the beginning, don't you have 2x squared over x squared?
Yep.
Yep, so either place you can get y equals 2. Okay? Alright, tomorrow, or Friday, we'll do practice test 3, so hang on to that one. What we'll do now is, let's do this extra practice that is actually part of your homework, so you may have already done it, but if you haven't, I'll do it with you. And, yeah, I would probably need to do it on another sheet of paper, or maybe you can squeeze it on here.
I squeezed it on.
Yeah, it's up to you, whatever you want to do. And then the back is some more practice like we're doing right here with asymptotes and holes. So let's sketch the front. Okay, these should be easy. The first few anyway, we should be able to fly through. A is we're on extra practice 1.3. This sheet was stapled to your BFF sheets. So what should A look like, Monica? It's a square root function that's moved over to -2. That's exactly right. What? Yeah, hurry up. All right. What about B?
You go to the right 5, up 1.
It's the same shape.
Yep.
So it's going to be exactly the same shape, but it's moved over 5 and up 1. Yep. See how easy these are? If you know the rules and you know the shapes. All right, what's going on in C?
You got the squaring function
And the squaring function is what shape?
the U shape.
The U shape of the parabola. And this one has gone down 2. Kids, you have to pay attention to whether the 2 is like that or whether the 2 is like that. If it's inside with the X, you're going sideways. If it's outside, you're going up and down. So that is a parabola down here. What's D?
The same shape, but you go to the right 2 and then up 3.
Same shape, right 2, up 3. Very good, Evan. Here we go. Perfect. All right, now E is a piecewise function. So we already graphed one of these today, but let's do this one. Make sure we got it. All right, so here we go. So this time my dividing line is going to be at 1. So I'm going to draw my line right there at 1. That's my dividing line. What? I put it right here, right here. This is where it always goes. Whatever the X part is over here, that's where the dividing line goes. Now, top shape is a
Squaring function.
square, so it's parabola.
Or probably.
And it hasn't been shifted or anything, so it's just a regular parabola. Intersects my dividing line right there. That is a closed-in dot.
Yep.
And see this right here?
Yep.
It's telling me I want the left side, so I will erase the right side. What's this equation? Y equals X plus 3. What's that?
Identity function.
That's an identity line, but it's been lifted up 3. So it's gonna look like that. It intersects my dividing line right here. That's the only point I care about, is where it intersects my dividing line. I want to keep that side of it, so that's an open circle, and I want to keep that side, so I'm going to erase this side. I'll get my dividing line out of there, and there's your picture. You feel like you're getting better at those? They're a little tricky at the beginning, but I think you get stronger as you go. All right, let's go through these couple more so this she can finish it up for you. Alright, so this time my dividing line is a little harder to see because it's actually the axis. That's my dividing line. What's that? 2x. That's a line with a slope of 2 over 1, and it starts at the origin because there's no like plus b on the end of it. So I'm just going to go up 2 over 1, up 2 over 1. I'm going to draw that line in like that. And this, remember, was the dividing line, so that's the point where it crosses. It's open, and it's pointing that way,
Yes.
so I erase this way. What's that? Identity down to?
Yeah.
So that one looks like that.
Yep.
And there's the dividing line right there. Solid. Pointing this way.
Yep.
Remember, one of your pictures you'll erase on the left and one of them you'll erase on the right every time. There we go. Now, the last piecewise here is a little bit trickier because it has two dividing lines.
Yes.
Don't get freaked out. We're going to have a dividing line at -2 and a dividing line at 1. Okay, so let me get those drawn in here. So a dividing line at -2 and at 1.
So if it does a 2, you just put them in both?
Mm-hmm.
Okay.
Yep, they're both dividing lines in.
I have a question.
Mhm.
Is Monday day 2? Because
No.
Friday's day 1.
No, Friday's day 7.
Day 7.
Tomorrow is not a day.
Oh, okay.
Okay, so here we go, top line. 3x, if x is, or 3x, y equals 3x. How do I graph y equals 3x?
Just go up 3 and
Up
over
3.
Well, I start at the origin
Yes, sir.
and go up 3 and over 1. So up 3 and over 1, there is my line. Now, be careful. You only care about this dividing line.
So if it's crossing.
So we don't care where it crosses the other one because the other one doesn't have anything to do with this problem. So we are only crossing at -2. So that is the only point we care about for this function. Because -2 is the only one mentioned for that top line. It's an open dot. And I'm keeping this part, so I am erasing this whole thing. This is the only part of that I care about. All right, what's this middle line? X plus 1, what's that?
That's the identity line.
The identity up 1,
Up 1.
so it looks like that.
It's on the 1.
It's intersecting the dividing line at 1 with a solid dot.
Keep the right.
And I'm keeping the right, getting rid of all of this. If you just do it one piece at a time, it's easy. Now, what's the bottom line? What shape is this?
That's the parabola.
That's your parabola. So I'm going to draw my parabola. Here it is. Now this time, see this right here, guys? I care about both lines now. So it's crossing this line here and this line here.
Yep.
And the -2 line is a filled in circle,
Yeah.
but the 1 line is an empty circle.
Yep.
And this time my X is in between those.
Yes.
So I'm going to keep the part in between and get rid of the part on both ends. Which makes sense because remember what I told you? Your dots will always have a solid and an open on top of each other. Is that what happened? I have a solid and an open on top of each other?
Yep.
And you'll never have curve on top of curve. So in other words, I would never have 2 pieces of curve on the right. I have one piece of curve on the right, I have one piece of curve on the left, and I have one piece of curve in the middle. Okay? All right. H. We're almost done with this sheet. I know you're acting like you're kind of bored. Hopefully that means you're all going to get A+ on your test. This is another one that you have to be careful when you graph it. I know you know what to do. You're going to take your exponential and drop it down 1. But the exponential is kind of a weird shape. Remember, it has an asymptote right here and goes through the point 0, 1. So I'm going to draw carefully my regular exponential. Then I'm going to drop everything down 1. Now, kids, that means that asymptote comes down 1 too. The asymptote comes down 1. So now the asymptote is down here. And when I drop the point down 1, now it's right there.
Oh, yeah.
So this looks like this. So the purple one is the answer to the question. It's the original exponential, everything dropped down 1. I is the same situation. Hopefully by this point you know which direction is this curve going. This is getting moved out.
That's left.
To the left.
Yeah.
So I'm going to start with my basic logarithmic function. Now remember, the basic logarithmic function has an asymptote here, and it crosses the x-axis here. That is my logarithmic function. But we're moving it, you said 2 to the left. That means this guy is going to be moved over here.
Yep.
And that point is going to be moved over here. So you're going to have that same shape, but it's going to look like that. Luckily, J and K aren't tricky at all. What shape is J?
Cubing.
It's a cubing function. And where's it going to squiggle through?
Positive 2.
+2, so it's going to be right over here at 2, 0, squiggling through. There we go. And now I've got my square root function that's been shifted around.
Shifted right.
Right 3 and up 4. So 0.3, 4 and my square root shape. Good?
Yep.
Turn it over. Come on, practice makes perfect. Don't act like you're bored. This is good stuff. Find the domain. Tell me what you know about any of them, A, B, or C. What do you know about any of them?
Under the radical has to be, if it's under a radical.
If it's under a radical, it has to be greater than or equal to 0. So in A, x plus 1 has to be greater than or equal to 0.
Yep.
So x is greater than or equal to -1.
And if the denominator.
And the denominator cannot be 0, so x cannot be 2.
Yes.
So that's the answer to A. What about B?
There's no problem.
That's all reals. Why is that all reals?
Since there's no problem.
No radical, no denominator, no problem. That's right. C. Exactly. Whatever is under the radical, which in this case is 2x minus 5, has to be greater than or equal to 0. So 2x is greater than or equal to 5, and x is greater than or equal to 5 halves. Vertical, horizontal, and holes. On the test, we're just going to list them, but I'll go ahead and sketch them on here and label them. Tell me what you know. For A, is there a vertical asymptote in A? Yes. What is it? Negative 5. So remember on the test, you have to write x equals negative 5. You won't be sketching it, you'll just be putting it in the answer blank, but you have to put x equals. If you just put the number, you're only going to get half credit. You have to put x equals for your vertical asymptote. How do you remember it's x equals? Well, there's lots of ways, but one way to remember is when you draw it, it crosses the x-axis. Whichever axis it crosses is the letter it is. So x equals negative 5, vertical asymptote. All right, what about a horizontal asymptote in this problem? Y equals 2. It is y equals 2, kids. That's your horizontal asymptote because you have 2x over x. That's 2 over 1. That's 2. That's your horizontal asymptote. Does problem A have any holes?
No.
No. Nope. No holes in A. Nothing cancels, nothing factors. We're done. A's done. All right, what about B? I can't help it. I just want to factor it. So I get x plus 1, x minus 1 on the bottom. X plus 5, x minus 1 on the top. No. Minus 5 plus 1. I caught myself because I did a quick FOIL in my head. I always FOIL to check my factoring to make sure it's right. And when we notice, woo, gonna have a hole. And the hole is going to be where? It's going to be a point.
It's gonna be 1.
It's going to be
Negative
where
1.
x is negative 1.
And
X is negative 1 because that's what canceled out.
negative 2.
And I don't know, I gotta plug it in. So negative 1 minus 5, negative 1 minus 1. I got
2.
negative 6 over negative 2. I got 3. Did I do that right?
Yeah.
I put negative 1 into my problem. So I got negative 6 on the top and negative 2 on the bottom.
Yeah, yeah.
So if I were graphing it, which you're not on the test, but if you were, you would have simply an open dot in the picture, a hole, big open dot at negative 1, 3. Do we have any vertical asymptotes at x equals 1? Positive 1. So your vertical asymptote is x equals 1.
And the horizontal is 1.
And the horizontal is also 1 because you have x over x, or in the original problem, x squared over x squared. Almost done. I promise I'll shut up here after we finish this. Alright, so we have x plus 1 over x plus 2, x minus 2. Am I going to have any holes?
No.
No, because nothing canceled. However, I am going to have two vertical asymptotes. I'm going to have a vertical asymptote at x equals negative 2, and a horizontal asymptote, or excuse me, another vertical asymptote at x equals 2. X equals negative 2, x equals positive 2.
Maybe a horizontal asymptote.
The horizontal asymptote is going to be at y equals 0. Y is the horizontal at
I was just
zero.
asking how coefficient.
Mm-mm.
The big
Bigger
ones on
numbers.
the
The bigger power is on the bottom. Look at the original problem. You have x over x squared. That means the asymptote's gonna be at zero every time, horizontal.
And then when the big ones on top.
When the big one's on top, then there isn't a horizontal asymptote. So look at problem D. Problem D is very boring because there is no horizontal asymptote. There is no hole. The only thing we have in D is a vertical asymptote at -1.
This works. Would you, if there was no horizontal level, would you want us to write that out or just leave it?
Well, you're gonna be filling in the blanks,
Oh.
so you'll write none in those blanks.
I figured like if we had problems like this, there were no.
No, there's no, you don't have to graph those, you're gonna just fill in blanks like on the crafty test. Okay? Are you ready? Okay, so, I'll see you again on Friday for a test on Monday. If you're turning in your homework for early credit,